Imagine an AI assistant that needs to understand weeks of continuous video footage to answer a simple question about your daily habits. Current video language models hit a wall after just minutes of content, but what if we could give them a memory that works more like ours? Building on this challenge, the researchers identified 4 critical problems blocking progress in long video understanding. Current approaches either lose visual details through text abstraction or fail entirely due to context length limitations. The authors propose WorldMM as a fundamentally different approach to this problem. WorldMM introduces 3 complementary memory systems that mirror aspects of human memory. Each memory type captures different information granularities, from fine-grained events to high-level patterns. This architecture diagram reveals how WorldMM processes long videos through 3 distinct phases. The system first constructs its 3 memory types from the video stream, then uses an intelligent retrieval agent to adaptively query these memories, and finally generates responses based on the retrieved multimodal evidence. Let's dive into the mechanics of how each memory system operates. Starting with episodic memory, the system divides videos into segments at multiple temporal scales simultaneously. Each scale creates its own knowledge graph, enabling retrieval at the appropriate temporal granularity for different types of questions. Meanwhile, semantic memory operates differently by continuously consolidating relationship knowledge over time. The system uses embedding similarity to identify conflicting or overlapping information, then employs language models to decide what should be updated or removed. Visual memory takes a dual approach to preserve details that text cannot capture. It maintains both a searchable feature corpus and direct timestamp access, allowing the system to retrieve visual evidence through similarity matching or precise temporal lookup. The retrieval agent orchestrates this entire process through an iterative control loop. At each step, it decides which memory to query, formulates an appropriate search query, and determines when enough evidence has been gathered to answer the original question. Now let's examine how well this approach actually works in practice. The results demonstrate substantial improvements across 5 different long video benchmarks. Most impressively, the system successfully handles week-long videos that would be completely impossible for traditional approaches to process. Ablation studies reveal that each memory type contributes differently to performance. Visual memory particularly helps with perceptual reasoning, while semantic memory shows dramatic gains on questions requiring understanding of long-term behavioral patterns. Beyond accuracy improvements, WorldMM demonstrates superior temporal grounding capabilities. The system consistently identifies relevant time segments with much higher precision than existing methods, validating its dynamic temporal scope approach. This utilization analysis reveals how WorldMM intelligently selects different memory types based on question characteristics. The system shows clear preferences for visual memory when dealing with perceptual questions, and semantic memory for relationship-based queries, demonstrating its adaptive intelligence. The iterative retrieval mechanism proves crucial for performance, with multi-step approaches significantly outperforming single-shot retrieval. This validates the core insight that complex video questions often require gathering evidence from multiple memory sources. These qualitative examples perfectly illustrate WorldMM's adaptive behavior in action. When episodic memory alone cannot provide sufficient visual context or relationship information, the retrieval agent automatically accesses the appropriate complementary memory to gather the necessary evidence. Like any breakthrough, WorldMM comes with important considerations and limitations. The authors acknowledge both technical and societal challenges that come with this capability. While pre-processing and computational costs present practical hurdles, the more significant concerns involve privacy and security implications of systems that can accumulate and reason over vast amounts of personal video data. This work represents a fundamental step toward AI systems that can understand and reason about extended video experiences. The adaptive retrieval paradigm could influence how we design memory systems across many AI applications beyond video understanding. WorldMM shows us that the future of video AI lies not in processing everything at once, but in building intelligent memory systems that know what to remember and when to recall it. Visit emergentmind.com to explore more cutting-edge research that's reshaping how AI understands our visual world.